My dear friends, after discussing for a while the indirect method of determination of boiler efficiency and doing the boiler audit, we would look into the practical case of boiler audit, that is problem solving. We would take an example where we would assume that we ourselves are doing an audit. We go to an industry, we take certain measurements, and we note down certain readings. Using those readings, we would be then calculating the boiler efficiency by the heat loss method or boiler efficiency by the indirect method. Okay, so this way that helps us calculate and understand the boiler efficiency more in depth. So let us just revise a few concepts before we begin with the actual problem solving. So what did we learn in the last few lectures? So we looked into the two methods, the direct method and indirect method. In the indirect method, we said that the efficiency is the difference between the energy input and the summation of losses. We talked about the standards for boiler efficiency test, which the auditors follow, the procedure which the auditors follow for doing the boiler efficiency calculations. And we said that the widely used test is not the direct efficiency test, but the efficiency calculations by indirect method. Okay. So in the indirect method, what we do is that we calculate the number of losses. For example, we would be calculating the loss via the flue gases. We would be calculating the losses because of hydrogen in the fuel, because of moisture in the fuel, because of the moisture which is present in air, then the heat loss because of incomplete combustion, and so on. Okay, so this losses, once we calculate, we need to sum up those losses and we arrive at the efficiency. So this we had discussed quite in detail, and the objective now is not to repeat this but just have a overview of this before we solve the problem. So what losses which are applicable to the liquid, gaseous and solid fuel? L1 is the loss due to the dry flue gas, which is the sensible heat loss calculated as mass of the flue gases into specific heat of the flue gases into the change in temperature, that is the flue gas temperature minus the ambient temperature. Then loss due to hydrogen in the fuel. We talked about this loss by saying that this hydrogen gets converted to water and this water is evaporated. Okay, and because of this evaporation which requires certain energy, there is a loss, overall loss in the boiler efficiency. Same thing about the moisture. The moisture is present in the fuel. That moisture will get evaporated and that would require certain energy. If there is a moisture present in the air, then we need to calculate that loss also, right? So I would take one small numerical which would demonstrate few of the losses, and that would help you understand and appreciate as to how these losses are calculated in the actual practice, and that would give you the confidence necessary for doing the energy audit on your own. Okay, so just have a look at the expressions before we begin with the problem. Okay, this gives you the formula where 100 minus L1 plus L2 plus L3 plus L4, L5, L6, L7, L8, all these are losses expressed on the percentage basis. Okay. So first thing is we need to calculate the heat lost via the dry flue gases, and for that we need to know the oxygen contained in the fuel, or we need to know the CO2 and CO in the fuel. Okay. So I will be now straight away going to the problem. Just have an overview of these formulas, the concepts before we begin with. Okay. So this slide gives you heat lost via the dry flue gases, and for that we need to estimate the theoretical air required, the excess air required, and the mass of flue gases. This is one conversion formula which we talked about, and this is the proper expression via the flue gases heat loss. So before just look at the formulas, and if you don't have the formulas in your notebook, just copy those formulas so that finally while actually solving and taking these values, you would not be struggling, right? So this is the expression. This is not dot. This is TF minus TA. 9H 584 plus CP TF minus TA whole upon the gross calorific value. This is the formula for heat loss due to evaporation of water. This is the heat loss due to moisture present in the fuel. All these formulas I had given, they are in the MKS units. We can also use the SI system. For example, if I want to use this formula in the SI system, I need to multiply this 584 with 4.187, so that the value comes in kilojoules per kg Kelvin. The CP value I would have to take in kilojoules per kg Kelvin. That way. This is the formula for heat loss due to moisture present in the air which is being supplied to the boiler. Okay. And this is the incomplete conversion. We talked about the incomplete combustion, and we said that if there is incomplete combustion, this is the loss. Okay, and these are surface losses. So after having an overview of these losses, now let me begin with the numerical proper, wherein you would be actually understanding, and your concepts would be very much clear as we solve the numerical. Okay, so let me take a whiteboard first, and let me write down this numerical. Okay, you should, I will not say you can, you should also write down this question with me, and try to solve the numerical with me. Okay, you can pause the video anytime if you are, and rerun the video if you feel that I am a bit fast. Okay, so let us say that you are doing an audit in an industry, and that industry has a boiler which is oil fired boiler. Okay, so when I am saying it is an oil fired boiler, there would be no heat losses because of the fly ash and bottom ash. Okay, we talked about this losses only when the fuel is a solid fuel like coal or biomass. So because now you are given that you are auditing an oil fired boiler, there would be no heat losses via the fly ash and bottom ash. Right, so let us say that you are doing an audit on a typical oil fired boiler, and you are taking some readings as auditor there. So first thing is, as auditor, you would do the ultimate analysis of the fuel. Okay, and that is given to you. That reading is given to you after analysis of the fuel. That is ultimate analysis of oil in this case is given to you. And you can always, as I said, practically speaking, when you do the audit, you should take the sample of the fuel which is used, and you should find out how much is the carbon present in that fuel, how much is the hydrogen present in that fuel, how much is the sulfur present in that fuel, and how much is the oxygen present in the fuel. This is done by ASTM, American Society for Testing of Material Standards. Using the standards you use into the analysis. And for example, after your analysis, let us say that you get carbon as 84%, then you get hydrogen as 12%, let us say you have a value of sulfur as 3%, and say oxygen is 1%. This is the fuel analysis is given to you, and also you must, using the bomb calorimeter, you can take a sample and find out the gross calorific value. And let us say that value is given to as 10,200 kilocalories per kg. Okay, this is, as I said, this value will be given to you by the plant manager, or you need to do your own analysis of the fuel sample as auditor. Okay, after analysis you will get this. So these things are now with you for finding the boiler efficiency. Then, as I said, you need to record the pressure gauge reading, and that pressure gauge reading would, let us say, as auditor, you record it and you find it as 7 kg per centimeter square. So approximately 7 bar. And this is a gauge pressure, as I said, so you need to convert it into absolute pressure, and it is given that the steam is dry saturated. That is, the dryness fraction is 1. Okay. Then you are given the feed water temperature. Feed water temperature you need to record as auditor by using the thermocouple readings on the indicator. Okay. If there is not given, then you need to actually go and record the feed water temperature if it is not given, okay, on the indicator. So let us say it is 60, not 70. In my numerical, I will take this value as 60 degrees centigrade. Okay. So 60 is the feed water temperature, let us say. And then you also need to note down the flue gas, combustion gases temperature. That is the products of combustion gases temperature also are recorded using thermocouple. And that as an auditor you are recorded it as, let us say, 220 degree centigrade. So the gases which are leaving the boiler, they are at 220 degree centigrade. Surrounding temperature also you must note. Surrounding temperature is, let us say, 27 degrees centigrade, which is recorded again by the auditor. Then the auditor does the flue gas analyzing using the combustion analyzer. Okay. So the flue gas analysis gives you the oxygen in the flue gases, that is products of combustion. Flue gases means products of combustion. And let us say that oxygen which is given to you is after the analysis gives you this value, that 7% is the oxygen in the flue gases, meaning that because there is oxygen in the flue gases, it means that the supplied air is in excess. Excess air is supplied over the theoretical air. Okay. That is another information you have. Then you can have the information about the specific humidity. Using psychrometric chart, you can find the specific humidity. Any instrument, you can use a dry bulb temperature and wet bulb temperature reading. And finally, using the property values of moisture, you can get specific humidity. Let us say that value is also given is kg of water vapor per kg of dry air. This is the value of specific humidity which is given, right? And then you are supposed to calculate the boiler efficiency by indirect method. So indirect method means you need to find the losses, okay, for getting the efficiency value. So first thing is we would find the heat lost by the flue gases. So heat lost via the flue gases is mass of flue gas into specific heat of flue gas into temperature of flue gas minus the ambient temperature. Now this is given, you look at this. This is given as 220 and this is also recorded. This is 27. Then you can assume this value as, let us say, 1.005 kilojoules per kg Kelvin, or in MKS unit you can take it in kilocalories per kg as, let us say, 0.25. Okay. So I'll take it as 0.25 for the flue gases, or to be more exact, I'm substituting it as 0.23 kilocalories per kg. Okay. So now we need to find mass of flue gas. So mass of flue gases is calculated as, this is very important. Okay, mass of flue gases is mass of air supplied plus mass of fuel. Okay, now mass of air supplied will be 1 plus the excess air percentage wise into the mass of the theoretical air supplied. And we have seen that the mass of theoretical air is calculated as 100 by 23, 8 by 3 carbon plus 8 hydrogen plus sulfur minus oxygen. Where this carbon is coming from the ultimate analysis, 0.84, Hydrogen is also coming from the ultimate analysis 0.12. Sulfur is coming from the ultimate analysis 0.03, and oxygen is also from the ultimate analysis of the fuel, which is 0.01. Okay, so if you do this calculation, and I would want you to do this calculation, you should get this value as 14 kgs per kg of fuel burned. This is a theoretical here. So this theoretical here I will take it as 14. Now most interesting thing is how do you find the excess here? Okay, and note down this, that what I will be doing, and this is the most important step, excess air percentage, and this formula you should remember. Excess air percentage is given by O2 upon 21 minus O2 into 100, and this O2, mind well, is the oxygen in the flue gases. It is not oxygen in the fuel, oxygen in the flue gases. So this comes as 7 upon 21 minus 7 into 100, which is 50%. I hope you have understood this. This is very important expression, that by knowing the oxygen in the flue gases, you can get the, by knowing the oxygen in the flue gases, one can get the excess air. So what I will do is that now I will put this value as 50 over here. If you find this a bit fast, you can slow down this video and you can convince yourself step by step what I am doing. Okay, so 1 plus 50 upon 100 into 14, and that gives me 1.5. This would be 1.5 into 14, and that is 21 kgs of air is being supplied per kg of fuel, per kg of fuel. Now this is very important. Okay, so what you have got is, in the next slide I will see, just write down this. So what you have obtained now is the actual air supplied, which is 21 kgs per kg of the oil burned. In this case, fuel burned. Okay, oil burned. Every kg of oil burned, you need to supply about 21 kg of air. Okay, and then what would be the mass of the flue gases formed? So mass of the flue gases formed would be, so mass of the flue gases is what? It is mass of air supplied plus mass of fuel supplied. Okay, so every kg of fuel means 1 kg of fuel. Every kg is 1 kg of fuel plus 21 kgs, so about 22 kgs of flue gases are formed. Okay, 22 kgs of flue gases are formed, and that helps you to calculate the heat lost via the flue gases, which is mass of flue gases into specific heat of flue gas into temperature of the flue gases minus the surrounding temperature. This is sensible heat loss. We have discussed this many times. Okay. So this is around 22. This is around 0.23. The temperature is 220 minus 27. And if you want to find percentage heat lost via flue gases, percentage as expressed as percentage of the heat lost as compared to the energy in the fuel. So this is 0.23 into 220 minus 27 upon what? Every kg into the gross calorific value, which is 10,200. So this into 100, if you solve this, okay, so this will give you around 9% as the heat lost by the flue gases. So this is the most important calculation. You must understand that how you calculate the heat of flue gases. First you find the mass of flue gases, and for finding the mass of flue gases, you need to find the actual air supplied, and for finding the actual air supplied, you need to make use of the readings, that is the oxygen in the flue gases reading. Okay, oxygen in the flue gases reading would help you calculate the percentage excess air, and then by using this expression 1 plus excess air upon 100 into mass of theoretical air, you can find the mass of actual air supplied. And note down that theoretical air supplied, we use this expression, which this expression depends on the ultimate analysis of the fuel. So you see that ultimate analysis has to be done if you want to arrive at the mass of the flue gases and finally the heat lost by the flue gases. Next is you need to calculate also the other losses. So I'll just quickly now use the formulas. Heat lost due to hydrogen in the fuel. What happens to this hydrogen? This hydrogen is getting converted to water vapor, which is evaporated, and this is the loss because it requires energy. No? So this process is it requires energy. So this energy is a loss. Okay. So this is for the formula is 9 into H2, 9H into 584 plus Cp into temperature of the flue gases minus temperature of the ambient upon GCV into 100. This formula is in kilocalories per kg. Okay. So Cp is also to be taken in kilocalories per kg, and this is Cp of steam now. This is Cp of steam, which is 0.45. Okay, 0.45 kilocalories per kg. If you want to do it in SI units, you must remember that 1 kilocalories per kg is 4.18 kilojoule per kg. Okay. So you need to multiply everything by 4.187. 4.187 if you want to get the value in SI units. This is 10,200 kilocalories per kg, and this is the hydrogen percentage which is given in the fuel. So this is hydrogen in the fuel, which is given as 12%. Okay, this is 12%, right? So if you solve this, you should get this value as about 7%. 7%. You do it yourself and convince yourself that you are getting this value. This is the temperature of the flue gases, which was given to be 220. This is 220, and this is 27. You already have these values, right? Similarly, if you want to find the heat loss because of moisture in the fuel, so moisture in the air, there is no moisture in the oil, so we will not consider moisture in the oil, but there is a moisture in the air which is being supplied to the boiler. So for that, we need to take the actual air supplied mass into the specific humidity, omega. Okay, omega value into the temperature difference, temperature of flue gas minus temperature of ambient upon GCV into 100. Okay. Now this we had already calculated. This is around 22. This is given to be as 0.018 kgs of water vapor per kg of dry air, and this temperatures we have 220. This is 27. This value I have as 10,200, like this. So if you put these values like this, 10,200, we would get again an answer, and this is a bit small, is around 0.3%. Okay, and because finally we would compute the loss due to radiation, okay, and other unaccounted losses, unaccounted for losses. Because this is a small boiler, you would use the thumb rule for a small boiler. Okay, so this way we have got the losses now. This sum of the losses, summation of the losses expressed in percentage would be what? First, we have found the heat loss due to dry flue gases, which is about 9%. Then this is flue gas loss. Then because of hydrogen in the fuel, which is about 7%. Then we have found about heat loss due to this, which is 0.3%, and surface loss is 2% like this. So somewhat like, so 9 plus 7 is 16, 16, 17, 18.3 or something like this. So around 18.3, or let us say approximately 19% are the losses. And then we get the boiler efficiency by the indirect method as what? 100 minus losses percentage. So this is 100 minus 19 and your boiler efficiency is 81%. Okay, so look at this. So now from this you can make out that, okay, so the losses, these are losses, these are the major losses, we need to do something about it. We need to go for boiler tuning, okay, and try to reduce this loss. We need to focus on this also, okay, and this way we get an idea of from the audit that, okay, if the rated efficiency was 90% and you are getting only 80%, we need to concentrate our attention on these three so that we can go closer to the rated value. So look at this. So the heat loss method or indirect method helps you to calculate the boiler efficiency and helps you to also do specific recommendations regarding the boiler efficiency improvement. Okay, so I hope that you have followed this numerical, the case study as to how we calculate the boiler efficiency by the indirect method or the heat loss method. Thank you very much.